Okay, welcome to the tutorial on how to use the new gRPC API found in the bchd Bitcoin Cash full node implementation. If you want more information about bchd or how to use it as an indexing blockchain server, I'd recommend reading this article here that we have posted on Medium. But this tutorial is going to be an introduction to the API primarily for developers. And maybe more broadly, it's going to be a bit of an introduction to gRPC for people who don't know what gRPC is or who have never used it. So let's first start with that. So what is gRPC? It's a new RPC framework that was created by Google. Google uses it internally quite a bit from what we read. And it is as we're going to see, it's a pretty massive upgrade over the kind of the JSON RPC that we use in Bitcoin. And the Bitcoin full nodes typically implement a JSON RPC API. There's Electrum servers and wallets kind of use a variant of that. And it's kind of a very old, crufty API and not very optimized. I mean, while it kind of works, as we're going to see, it's a lot more complicated and difficult to use than gRPC. So we're going to see gRPC has quite a few advantages over JSON RPC, which we'll get to. As far as languages go, gRPC is available in just about every major language, and you can look at these tutorials on the website for how specifically to use it. But there's a couple of things you're going to need is the libraries to use gRPC itself, and you're also going to need the protobuf compiler with the gRPC plugin. And that's going to basically auto-generate language bindings. We'll see how this works in a second for pretty much any of these languages. So basically, every major language that you would want to use it in, and even ones that aren't listed here, you can find gRPC implementations on the internet as well. So with this tutorial, I'm going to use Go. Just because I kind of like that language, but we could have done this in Python or C++ or Java or whatever. Okay, so the first step to using gRPC is you need to understand the protofile. So if I come to, this is our GitHub repo for bchd, and if you look at this is the new package here, bchrpc, that we added. And if we come down here, we're going to find this bchrpc.protofile. This protofile is what you are going to need if you want to implement either a client or a server, right? If you wanted to create a compatible server that is compatible with the API, you'd also need this exact same protofile. And if you're trying to implement it from a client side and use it from a client side, you're going to want to download this protofile here as well. So right off the bat, what we're looking at here is this protofile defines a service, the bchrpc, and it's basically defining the different endpoints that are available in this API. So we can see get mempool info, get blockchain info, so on and so forth. We define all of these endpoints in the in this protofile. This protofile serves as the canonical API contract. So this is already one of the main benefits we're seeing of gRPC is we don't have to go hunting down API documentation like you would with other APIs, or you don't have to deal with poorly documented APIs or anything like this. This is the spec, right? This is the spec, and it doubles as the documentation, and it's really difficult to misinterpret or misunderstand what this is actually saying. So let's just take a look at like get blockchain info. It takes in a get blockchain info request object, and it returns in a get blockchain info response object. So what does that look like? Well, we scroll down a little bit farther, and here's the request, which is just an empty struct, and then here's the response that it would give you back. Okay, and it does this for their structs defined here for basically every one of these RPC calls. We also see that we have let's look at this one. We have streaming RPCs, right? So one of the main advantages of gRPC over other APIs is we can do both unary APIs as well as streaming APIs all in the same framework, right? We don't have to do, like, for example, what they do with the Insight server, where you have this like combo API. You have a REST API for certain types of data, and then you have to go messing around with like WebSockets and Socket.io if you want other types of data. This handles it all in a single API, right? JSON RPC doesn't even have streaming APIs, which leads to really terrible solutions like long polling, for example. So all of this is all bundled together nicely in a single package. This uses HTTP2 with stream multiplexing, so there's no head of line blocking, and it just works really, really well. So let's get down to it using this in the actual code. I'm just going to use, we'll just use Atom here. It's a real small tutorial. Let me just set up an environment real quick. We'll call it, I don't know, RPC client. Okay, so step one to building out this this client is going to be to grab. We want to actually download this proto file, as we're going to see we're going to need it. So let me just grab the raw here, and we'll wget that. Okay, so here's the proto file. I'm going to create a new. I'll create a new package. We'll call it. I'll just call it PB, right? And then next thing we're going to want to do is we're going to use the proto-C compiler, the protobuf compiler. It's going to basically auto-generate all of the client code for us. Now, when I say it's going to auto-generate the client code for us, I just want you to show you what the JSON RPC looks like, the code for the JSON RPC. So just to write a client that can interact with a JSON RPC API, we have this here in our bchd repo. But this is the RPC client package, and each one of these is like hundreds, if not thousands, of lines of code. Each one of these files inside this package, which is needed to be written just to interact with the JSON RPC API. Before you can even start consuming the data, before you can do anything, there's just this absolute massive amount of boilerplate code that needs to be written. And that's just one file in here. And this isn't even it. This RPC client package is not even it, because we still have all the serialization code, which is in this package, BTC JSON, which, look at all this. This is all for serialization. So each one of these, and that's actually a small one, but each one of these is, usually hundreds of lines of codes, as I keep picking small ones. But you get the idea. Each one of these has tons and tons and tons of code just related to the serialization and deserialization of the objects that are coming in and going out. So this is all, either if you want to interact with these type of APIs, you either need to find a library like this one that's already written that you can use to interact with it, or you're just going to have to write these thousands of lines of boilerplate code before you can even start consuming the API. And that's what the compiler is basically going to do for us. This is basically the magic of gRPC. So just to give you an example, I'm going to do proto-C. We're using Go, so it's going to be go out, and then we're going to use the plugin, our PB package, and then we're going to give it the name of the file that we want to compile, which is the bchRPC proto that we downloaded. And there we go. And if we look inside our PB package, it just dropped in essentially an auto-generated file here, where it just generated literally thousands of lines of code for us. And that's all that client code that you saw that we had to write just to interact with the JSON RPC API. We don't have to write any of it to interact with the gRPC API because the compiler does it for us. And that compiler, we just compiled it to Go. But again, as I said, it'll work for every major language. You want to do this in Python, you want to do this in Java, you want to do this in C++ or JavaScript. The compiler will compile it into basically everyone. You might not have to use specifically the Proto-C compiler. There might be other ones, and you'll have to look it up based on the documentation here by the language documentation. But it'll have the same effect in that it'll auto-compile all the code. This is all the serialization, deserialization code, everything. So let's just write something that actually uses this, right? Okay, first thing we're gonna need to implement or import a couple things. So I'm importing the gRPC. This is a gRPC Go library, and we're going to want to create a connection. And in particular, we're going to be connecting to, we have a public server running at bchd.grayh.at, and it's on port 8335. And this is going to be uses TLS. So by default, bchd will always use TLS. If it's this is a Let's Encrypt certificate, so this is an actual signed certificate by a certificate authority. If you don't use an actual SSL certificate, bchd will generate a self-signed certificate, which you can also use. It's just you need to distribute the self-signed certificate to the clients, so that you would put like an extra line of code in here to use the self-signed certificate. But in this case, because we're not using a self-signed cert, we're just going to do with transport credentials, and then we're going to import the credentials package. Come on. Alright, give me the hints. Oh, gotta love Adam. There we go. I think we want this one, and it's just going to be nil, and the server name is just going to be an empty string because we're using a TLS certificate. Okay, and then just handle the error. Okay, that's the connection, and now to get our client, we're just going to import that PB package that we created. Right, new bchRPC client. Again, this is from that auto-generated package that was created, and we're just going to pass in the connection, and there we go. We have a client. So look at this. I mean, we're looking at like 4 lines of code. So instead of writing thousands of lines of code in order to interact with this API, we've written 4. Okay, and then what you can see from here to use it is the client will give you, or you can get like IDE hints, using depending on what IDE you're using, and it just shows you all of the RPC calls that are available to you right here and how to use them, right? And the documentation on how to use them is just right here. in the IDE. So let's just check out, we'll look at get blockchain info. It's going to take in a context. And this is a get blockchain info request object, and I think we remember, did I spell that right? I think I did. Remember, the get blockchain info didn't take, it was just an empty struct. Okay, and this is just going to give us a response. Okay, and then we'll just print out the response here. Okay, so that's it right there. It's just a couple lines of code. This is the response. This is just the way Go prints it. But what's being returned here is essentially, remember, this was the get blockchain info response object. So this is a strongly typed object. So if we want to use the actual data, we've got methods right there which tells us all of the data available from the response. So like if I want to print out the height, we can do that. Right, that's the height of the chain right there. Okay. We could even go, now if for some reason you wanted to, you could have some code that wanted to marshal this object to JSON. You don't need to because you already have the object is right where you need it to be in your code and you can use it right there. But if like you wanted like, I don't know, pretty print capability, for example, we have a, or you could write some code to dump it to JSON, which we have in our bch util package. Okay, we run this again, and like you could get a dump to JSON. We had to patch this JSON PB a little bit so that it will print the hashes the correct way and this sort of stuff. But right, so there's the data. So let's just take a look at a few other APIs. So let's say we wanted to build an SPV wallet, and so we wanted to download the headers from this API. So let's just take a look at that. First, let me grab a, I don't know. Let me grab a block from the blockchain. I'll use the Explorer here. I could be using the API to do this, but Genesis block maybe. Okay, internet's being nice and slow. Let me do import that. Alright, let's do get headers is going to be our API call, and then this would be the get headers request. This one is going to take in some data, so this is taking in This can take in the block locator hashes and a stop hash. So this is the same type of data that you would give if you were doing a get headers request on the wire to an actual Bitcoin node using the P2P protocol. Okay, so in this case, I'm just going to do, we're just going to pass in the Genesis block here. And I think that's it. No, it's not it. Okay, so there's all of our block headers. This returns a batch of block headers, so then you'd have to go and request the next batch. But if you were building an SPV wallet, you could easily do that on the API. Let's take a couple other examples here. Let's do we'll do get block request, and this takes a hash or height. I don't know, let's do block 580,000. We don't need this anymore. What's it complaining about? Oh, I'm going to change this to get block. Okay, so this is the printed the block header and then just a bunch of hashes. Let me grab one of these here, and I'll just show you the Merkle proof. Import that chain hash again. Oops. I think it's get Merkle proof. And this would be get request. Right, and so there's our Merkle proof that this, the hashes that this transaction goes with that header, right? So we could build an SPV wallet this way if we wanted to, and there's a lot of other APIs. I just want to give you one more example of how to use the streaming API, because as I said, this can do streaming. It can do server to client streaming. It can also do bidirectional streaming. We do have a bidirectional streaming API, but let's just use the subscribe transactions API, and this would be a transactions request. Which I spelled wrong. Okay, so we want to subscribe, and we're going to give it a transaction filter. And we could be filtering on, this gives us a number of filter options. We could filter on addresses, data elements, outpoints. In this case, let's just download all transactions here. And then finally, we could have it send us transactions when they are included in the mempool, or when the transaction confirms and makes it into a block, or both. In this case, we'll just have it send it when it's included in the mempool. This is going to return a stream. And then just wrap this in a for loop. Right, and we're just going to call stream.receive there, handle the error, and then we're going to want to print out the transaction. Okay. Whoops. We don't need this anymore. Or that. Okay, and so this is just printing out transactions whenever a new transaction comes over the wire in Bitcoin Cash. Right, there's a couple new ones coming in. Right, and it basically gives you pretty much all the data that you would need: addresses, disassembled scripts, what have you. If you have indexing turned on, you have a couple APIs that are available to you there's a transaction index and the address index. So we have where's the get address transactions? There it is, get address so you could give it an address, it'll get back transactions. If you wanted the UTXOs for a particular address, there's an API to call that. Yeah, so it should have just about all the data you would need to build whatever kind of application you wanted to build on it. Submit transaction, what have you. Okay, and you can see we've written next to no code here compared to the thousands of lines of code that we wrote in or somebody didn't write it, but someone else wrote this code for the BTC JSON here. We didn't have to write any of it because the compiler just generated it for us. So last thing I want to talk about is the web. So gRPC, the gRPC spec actually doesn't work directly from a web browser because it needs access to like the low-level HTTP2 frames, which the browser doesn't have access to, and I think a couple other reasons. So what they actually did was they created a new, like, modified gRPC spec just for the web. You could think of it as like a different dialect of gRPC. And so this is the library that you'd use right here if you wanted to access it from a web. There's a little hello world guide. Now the normal way that you would use the gRPC web, which you can kind of see right here, would be to set up a proxy server between bchd and the web browser that would read the gRPC from the bchd node, translate it into the gRPC web dialect, and then it would be usable from the web browser. But because we are like to be kind of bleeding edge here in bchd, the bchd server is multiplexing both protocols, gRPC and gRPC web, over the same port, so you don't need to configure any proxy servers. If you want to hit the server from the web, you should just be able to use this gRPC web library and get going. And again, you can see, like, once you compile the code, like, this is it. This is your hello world code right here from JavaScript. It's like next to nothing, right? Okay, so that's it with gRPC and the bchd API. There's probably stuff that I left out here, but I hope you guys have fun building some applications, and I hope you find this useful.